In the past, the time for Jeff's journey to work had mean 45.7 minutes and standard deviation 5.6. This year, he's trying a new route, and to test whether it's reduced his journey time, he finds the mean time for a random sample of 30 journeys using this new route. Carries out a hypothesis test at the 2.5% level. Assumes that for the new route, the journey time has a normal distribution with standard deviation 5.6. In all our calculations on this A-level, we always use the same, unless otherwise stated, we always use the same standard deviation as the original. States, no, I mean, sometimes you have to assume that in the question yourself. So state alternative null and alternative hypothesis. So we're going to say for H naught that mu is equal to 45.7. And we should just define what mu is. And then H1 is that it's gone down because he's looking for whether it's reduced. Okay, then we're asked to determine the rejection region for the test. So I'm going to go through the normal process. I'm going to say let x equal journey time. I'm going to assume h naught is true. So then x, according to this model, for a single journey, would follow a normal distribution with mean 45.7 and standard deviation 5.6. So I write 5.6 squared here. But remember, we do not, because we're doing a random sample, we actually need to construct a sample distribution. Because what this is doing is finding, so I always find that people get confused by this, as I did once upon a time, but we're finding lots of different values, in fact, 30 different values, and then we are actually finding the mean of them. And what happens is that they don't follow the original normal distribution. They follow their own normal distribution that's actually going to be less, have a smaller spread, because if you imagine finding 30 values, you're very unlikely to get a value around here. And it follows that we actually divide our variance by the number of in your sample, and then sigma, or the standard deviation for this sampling distribution, is 5.6 over root 30. So you must remember that, okay? It's that every single time for the normal distribution. That's the key thing. Even if you can't quite wrap your head around it, I mean, please do read some more around it. There's some nice, I've kind of tried to show it graphically here. I've got a video up, I think, that talks about it and takes different samples and show what is happening as n varies. But at the end of the day, we are taking lots of samples, finding the mean. It's still going to be the mean of that is still going to be the mean of the original, but it's now like a reduced distribution. And the more you take, the more and more kind of squashed it gets. So there we go. There's our sampling distribution. And we can now find probabilities with that sampling distribution, but we're asked to actually find the rejection region. So here's my distribution. Here is my critical value. Okay, so that's going to be the cutoff for whether I accept, do not reject or reject any data that would follow from Jeff. But we don't actually have data, we're just asked for the rejection region. And what we do is we say this area here is going to be 0.025. And then the probability that this x bar is less than 0.025. Sorry, what am I saying there? That's not right. Probability that x bar is less than c, the critical value, that is going to equal 0.025. And we can then do inverse normal to work out this critical value. And from that, we can get the rejection or the critical region. So it's back to inverse normal, but the area is 0.025. This is very important. It's going to be 5.6 divided by 30. Mu is 45.7. And that's everything we need, actually. And we get 43.6961. And so it was accepted in the answers to write down 43.6, because actually 43.7 technically wouldn't be, but I just rounded it to three significant figures, which was okay as well. So that's the critical value. Rejection region is then anything, including that what's to the left. Rejection region is going to be x bar less than or equal to 43.7. So if Jeff did his 30 journeys and got the average to be 43.5, he would be rejecting H0. His journey time has decreased, whereas, well, there's sufficient evidence to say that at the 2.5% level. Whereas if you got 44, okay, it's gone down, but it's not statistically significant. We would actually not reject H0 on that basis and say, yeah, okay, there's insufficient evidence to say that the new route has reduced his journey time. Anyway, hope that makes sense. Keep practicing these. Well done.